Hi everybody, so this is a video on the absolute value function, or an intro to it. Some of you have seen this before, some of you worked on it last year, others of you have seen it and maybe have forgotten a little about it, and others may have never even seen it before. So maybe this is just a review for you, maybe this is completely new information for you, but either way we're just going to do a little overview of the absolute value function, which we're going to be working on today and tomorrow and maybe another day at the end of this week. So the absolute value function is written like this. There's these two bars, basically just two vertical lines that surround whatever is inside. In this case it's x. So the basic, the parent function, which we'll learn about later this year, of the absolute value is just y equals the square root of x. Okay, so it's the most simple form. Okay? And what the absolute value function measures is the total distance. So this is the total distance to 0. Okay? So basically what it is measuring is the total distance between this number and 0, whether it's positive or negative. So the absolute value function is actually the first example that you guys have probably seen of what is called a piecewise function, which we will go over as well later this year. But it's broken up into two parts depending on where on the number line x is. So if x is a positive number, we define the absolute value of x as just equal to x. So basically what this is saying is that the absolute value of 2 is just equal to 2. So that should make intuitive sense. If you have 0 on the number line here, and I have 2 here, the absolute value function is telling me the total distance to 0. So I know that this distance right here is just 2. Okay? So when I say that the absolute value of x is equal to x, if it's positive, it's just going to be the same exact number that's inside of the absolute value. Now, if x is negative, it switches over, and this might be a little bit tricky, but we'll think about it this way. So if x is negative, the absolute value of x is the opposite of x. So think of this negative as the opposite. So basically, what it's saying is that if I have the absolute value of negative 2, in this case, negative 2 is my x, I want to take the opposite of negative 2, or negative 2, which is just 2. So we can see that these two numbers have actually the same absolute value. So we're going to come over here, and you should be able to see that if you graph this, the distance between negative 2 and 0 is again just 2. Even though it's a negative number, the distance is always positive, so this is just 2 as well. I'll write it down there. Okay? So we break it up when x is positive, when it's negative. Basically, we're taking the distance between whatever's inside the absolute value. So if it was, if we had the absolute value of 6 minus 4, what we want to do is evaluate what's on the inside first. So we'd evaluate this 6 minus 4 is 2. So this would become this, and then we'd figure out that the absolute value is just equal to 2. Okay? So that is what the absolute value function is. And now we're going to kind of look at how we can use them to solve it. And going forward, we're going to learn about it as a function and features of it as a function, so that we can learn how to graph it and use it to solve more complex equations. But here is our general overview of how to solve absolute value equations. Okay? So to solve absolute value equations, we're going to split up our equation after we have isolated the absolute value. So I'm going to give you an example of this. That might not make sense, but it's a little bit different than how we would normally solve with linear equations, or purely linear equations. So you can see I have an equation right here. The absolute value of 5 minus 2x plus 2 equals 11. Okay? So we need to isolate, our first step when we're doing these equations, we need to isolate the absolute value. We don't have to do anything yet with what's inside, we just need to get the absolute value by itself. So normally we try and get x by itself. In this case, we're going to start off by trying to get the absolute value by itself. So in this equation, I'm going to start off by subtracting 2 from each side, which is just a normal inverse equations that we're doing, minus 2, minus 2. So this gives me the absolute value of 5 minus 2x equals 9. Okay? So now I have isolated my absolute value, and at this point, we're going to split it. So this might not seem intuitive, but there are two actual solutions to this equation, not just one. Okay, so what I'm going to do is I'm going to draw a little tree here. And what I can say is that now I'm going to take, the reason that we split it is because remember that this is split between when x is positive and negative. We want to split it because we want to take into consideration that feature of the absolute value function. So what we're going to say, we're going to get rid of now the absolute value. So you can see here on the right side of these equations, we've gotten rid of the absolute value signs that are around the bars, and we want to do that because otherwise it's kind of hard to solve. Okay, so I'm going to say that now I'm going to get rid of the absolute value bars. I'm going to say 5 minus 2x equals 9, or, so there's two possible equations, or two possible solutions, or 5 minus 2x equals, and now we're going to take into consideration this part down here, that it could be the opposite of something, equals negative 9. Okay? So basically all I've done is I've taken away the absolute value bars around on the left, and then on the right side I've made it a positive and a negative of whatever's on the right side, whatever's on the other side of the absolute value. Once I've split this up here, I'm just going to solve it how we would normally solve for a linear equation. So I'm going to get x by itself. I'm going to subtract 5. So I'm going to say negative 2x equals 4. If I divide by negative 2 on both sides here, I get x equals negative 2. For this problem, so I'm done here. So I've figured out the solution to this problem. I have 5 minus 2x equals negative 9. I'm going to subtract 5 again. I'm going to do actually the same exact process. I'm just working with a different number over here on this side. So this would give me negative 14. If I divide by negative 2, I get x equals 7. So x equals negative 2 or x equals 7. They are both legitimate answers. The correct equation to both of these would be to tell me both of these, not just one, but either of them work if you plug them into the function. So if I plug negative 2 into this function again, I would say that negative 5 minus 2 times negative 2 would be 5 plus 4. That would give me 9. The absolute value of 9 plus 2 equals 11. So 9 plus 2 equals 11. We're good. We can check this one by plugging 7 into the equation. So I have 5 minus 2 times 7. So 2 times 7 is 14. So 5 minus 14 is negative 9. I want to take the absolute value of negative 9, which is just 9. So I have 9 plus 2 equals 11, which makes perfect sense. We found both of our solutions, and so we have successfully solved this equation. One last thing that you guys should know, we'll get into this a little bit more tomorrow, but the graph of an absolute value function looks basically like a V. It looks like this is the parent function if we graph that. And that's because if x is negative, our equation is y equals negative x, which you can see here. This is just a line that has a slope of negative 1 and a y-intercept of 0. And then when it's positive, it's just the opposite. It has a slope of positive 1 and an intersection of 0. So this is the general graph of an absolute value function. If you see that, you can use that if you see this graph, you'll know, oh, I'm working with an absolute value function. So this is just an overview of the absolute value function. We'll get into it more tomorrow or Thursday. But here are some problems. I will give you some practice exercises to work on solving some equations, and we can move on from there.